First, let's talk about thunderstorms. So, first off, thunderstorms are basically just a storm with lightning and thunder in them. And there's actually not a lot that actually is required for a thunderstorm to get put together. And in Investigation 11A, you're actually going to be piecing together a certain situation and then determining, was this situation favorable for thunderstorm development? So here's what you need to know. First off, thunderstorms really only need 3 things to get going. The first thing they need is lots of moisture. And a big reason why is because moisture acts as fuel. This is the storm's food. Then you need some kind of trigger mechanism, something that takes all of that moisture and pushes it up into the atmosphere so that it can condense into giant cumulonimbus clouds. And then the last thing you need is some kind of supportive upper level winds. And this is important because this allows that trigger to be enhanced. And usually what we look for as meteorologists is what's called a jet streak. Basically a portion of the jet stream that has even faster than typical winds blowing in it. And the way that it works, if I were to, I'll just do this right here using my pen. If I were to actually draw the jet stream, it might look something like this. And let me actually draw a few lines, because when you're looking at an upper level map, that's what you see. So these lines right here represent upper level heights, and so on. Well, what actually happens is, whenever you have a situation like this, what we have right here is what's called a trough. And then the thing in between here, the center of the trough, is what's called the axis of the trough. Now what actually happens is right at the axis is where we get that jet streak. And I'll circle that here in red. So usually what happens is, over here on the eastern side of the jet streak is where you get favorable upper level conditions. And really the main thing you're looking for is what's called divergence. Basically you'll notice, and I drew it a little bit more over here, but basically these lines begin pulling apart. And that actually causes what's called divergence. And then in order for divergence to happen, or a result of divergence, is that air from below rises up to take the place of the air that's spreading apart. And so that's a major lifting mechanism that's necessary for thunderstorm development. Now with that said, I actually pulled out a couple of maps that are a little bit more current rather than the ones that you're going to be using in this exercise, partially because I didn't want to give away the answers. But let's talk about what's happening here. So here we're at the surface, and over here in particular, there's actually a lot of green, yellow, and then if you actually look closer towards areas like Boston over here, or down here towards New York City, there's actually a lot of red. And typically when we look for thunderstorms, that's what we look for. We look for those centers of heaviest rain. And if you actually notice, just to the west of this, we have a cold front. Well, a cold front is a triggering mechanism. It is actually something that can cause uplift to occur and then cause thunderstorms to develop. Now, as far as moisture is concerned, we can actually determine if the air is moist or not by looking at the dew point temperatures. And I don't want to give away answers, but here is what I'll say. So let's look over here. Let me pull out my laser pointer. Let's look at these regions ahead of the front. And if you notice, a lot of the dew points ahead of the front are relatively high. So remember, dew point is the lower left number on a station model. Down here in Key West it's 70, up here in Tampa it's 69, over here in South Carolina 67, 64. So we have dew points primarily in the 60s, 70s, a little bit of 50s up here. But watch what happens as soon as you go behind the cold front. So now you're on the other side of the front. Dew points are in the 40s, 30s, and even 20s. So what this actually points out is that there's a lot of favorable a lot of favorable moisture, a lot of favorable necessary moisture here at the surface. Now, speaking of upper levels, the other thing that is present right around the same area is a jet streak. And let me tell you how I know that a jet streak is here. So this map right here, this is the 300 millibar contours isotax map. You'll see one of these in the next activity or the next investigation. But if you actually notice, pretty much all along here, so pretty much all along the mid-Atlantic region, over here into the Ohio Valley, and then over here into the Mississippi River Valley, there are very, very fast blowing winds. That is indicative of a jet streak. And then over here on the eastern end of this jet streak, all of these contour lines are starting to pull apart. That is divergence, and that is a triggering mechanism for thunderstorms. That is a favorable thing for thunderstorms to develop. And if we were to go back to our previous map, what do you know? Right there, right off the northeast coast, we have thunderstorms. And right over here, we have the favorable environment for thunderstorms to develop.